Oh, I'm sorry.
It's easy to get
On local global term analysis for finding differences between different communities in social networks. And this is joint work with my colleague, Yi Ron, and our advisor, Srinivasan Parthasarathi. We're from Ohio State. So we're looking at social networks, and within them, there are sets of communities. So we want to say in a broader social network, there's groups of communities who focus on a certain topic related to terms, and also who are interconnected between themselves in, for instance, friend or interaction network sense. So one theme of this work is combining the network and content aspects. So some motivating questions we can ask about this is, if we're given a community in a social network, how can we tell what this community is talking about different from what people are talking about in the broader social network? Or if we're given two communities, how can we say what one is talking about and the other is not, and vice versa? So what we present is a four-step process by which we can determine this. So the first step is community discovery, where we just look at how can you find some communities, and which we mostly reference a lot of other works. Secondly, then we talk about how we can take the content terms that this community mentions and accumulate them. Thirdly, how to visualize this in a way that teases out the difference between different communities. And fourthly, handling time-varying data. So I will go through each of these four steps in turn, then I'll present some case studies, and then I'll conclude. So for community discovery, for this part of it is where we involve the network, and we use content throughout all the other steps. So for the first step, community discovery, we basically present two different ways to do it. The first is to first, in the social network, find a set of users that matches what we're looking for based on keyword type searches. So this is a pretty common way to start. Then, once those users are found, find the induced network of them, the connecting edges between them, either with friend-follower relationships or interaction networks. And the ones for which there's some dense interconnections, we would extract that out, and we'd say, here's a candidate community. So we suggest there's quite a number of works on graph clustering, which we present some here, or you could use modularity, or to involve content in helping to find these communities. There's some work on something called viewpoint neighborhoods. So there's quite a number of ways that you could start at finding terms at the top, and then secondly, go down and find interconnected networks. The other way to go about it would be to look first at the network and secondly at content terms. So you could take a large social network, perform some graph clustering operation on it, find these different clusters, and for each one extract some of the most common terms or most discriminative terms that they talk about, and select a candidate community from among those. So these are two different ways to go about community detection. They're sometimes domain specific, so the main contribution of our work is later, but this is a necessary prerequisite to doing what we want to do. The second step is extracting terms from the communities and accumulating them. So here we say you can look at, for each user, when they mention some content in the social network, find each of the terms that they mention. For instance, here, so on the previous slide, I have a toy social network, and we want to look at this group of users 1, 3, and 5. We've extracted them as our community of interest. And so here you can see we're accumulating all the different terms that each user has mentioned, and we'll accumulate the ones for 1, 3, and 5 as representing this network. So these can also be weighted at the time that they're extracted, like by either just simply by term frequency, so you mention it and that counts as one, or something more IR related like TF-IDF, which will give more weight to more discriminative terms. Or lastly, this may just be domain dependent. You may say certain terms have more weight in my context than others. And merging terms would be a next step where you may say that two terms are actually synonyms in my context, or I have some ontology and I can say that one term is a type of another term. All right, so once this is done, terms are aggregated by user, and then for all users in the community, we further accumulate those terms. So basically what we want to end up with is a term frequency distribution for the community, which we can compare to the term frequency distribution for the network as a whole. So we refer to the community of interest as the local group. So lastly, the step that we look at is visualizing these, because our work is to present a visual analytic framework for this. And what we do is plot the terms by their statistics. So on the y-axis, we'll put the global statistics, so the term frequency distribution out of the entire social network, for instance. And on the x-axis here, we can plot the local statistics, meaning for this community of interest, here's their term frequency distribution. So we can see in this toy example that, for instance, certain terms are much more relatively frequent locally than they are globally. So these, we say, can sort of define the community and how it's different from the social network as a whole, whereas this community does not talk about health as much, relatively speaking, because it's much more frequent globally than locally. So we can imagine this blue line is a regression line, a best fit. Fourthly, handling time series data. So right now, this slide is quite sparse, and the reason is that this is a work in progress, but one easy way to handle time series is to just divide the time range into some buckets, process each bucket independently, and then just do the previous steps for each of the time ranges. So I have an example of this, and I'll also show some ways in which we think it can be improved in the future. So on to our case studies. In our first case study, we took a social network of about 1 million tweets, and we wanted to look at users of different kinds of cameras, different kinds of photographic cameras from Canon, Nikon, and Olympus. And here, if we show along the x-axis users of Canon cameras plotted against the social network as a whole, and in the second plot, we show those for Nikon cameras, and one observation is they look pretty similar. For instance, Nikon talk more about iPhone. They both talk more about photo, some kind of fairly expected results. But if I replace this Nikon image on the right with the Olympus case, we can see that for the users of Olympus cameras, we found that instead of blog and post being roughly as frequent as in the broader social network, they talk about them a lot more frequently. So here we show that there's a certain local exaggeration used with these terms. So this shows how we can compare different related communities, the community of Canon, Nikon, and Olympus, and say something different about them. So this graph shows on the x-axis the frequency for the community talking about all the cameras as a whole, basically the union of the Canon, Nikon, and Olympus communities. And again, we can see some expected results in the local domain. So they talk about photographs and shooting and weddings and things like these. And also we can see relatively infrequently they talk about terms like health and teeth and learning. And these, we think, should probably have some more, be looked into further. But we can see how immediately just looking at visualizing the results this way, you can see a lot of interesting trends, some of which immediately make sense and others which should be looked into. So here I show some ranked lists of this. Basically shows the terms by distance from the regression line. So the ones furthest from the regression line are kind of most distinct, most discriminative for the community. And you can see, sorry, I have some, so photograph and shoot are quite far from the regression line in the local domain, and there's others which are, we'd say, anti-local or more global. They're less local. For a second case study, we looked at some Occupy Wall Street data, about 2 million tweets from that taken during November 2011 throughout the month. And for this, we look at Occupy Oakland members. So Oakland's one city in California. And as opposed to, on the y-axis, we show the broader community of everybody related to the Occupy movement. And so we can see some sort of expected results where people from Occupy Oakland, California talk about several California cities relatively much more frequently. We can also see some interesting cases like, for instance, Wall Street is much less relatively frequently talked about by them. Also this P2, which turns out to be some progressive online conservative group, and TCOT, which is some top conservatives on Twitter. So we can see that they talk about these terms relatively less frequency, as well as protesting and NYPD, the New York Police Department. So that shows some interesting results. Secondly, we have a temporal example. So I broke down the data by each of 4-week intervals, 4-week-long intervals. And this shows the first one. So we can see one thing in here. I'll kind of show the weeks in turn. So Wall Street here is kind of circled in red and appears kind of consistently as being an anti-local term. So although going back and forth, the data kind of, it seems to jump around a bit, we can see that some terms are more robust than others in terms of where they lie in the plots. And secondly, so this is the third week. I'll point out there was, some terms pepper spray that co-occur here together. And there was an incident where a police officer pepper sprayed some relatively passive protester, and this video went viral. Oh, I see, thank you. And so we can see that it really leapt out here in this third week, but if I move to, say, the fourth week, it has disappeared. Or if we move back to the third, back to the second, it's also simply didn't occur before that. So we think this method can reveal a lot of sort of interesting outliers or standout characteristics of the communities because, for instance, it's not really that frequent of a local term, not more than a lot of other terms. So having just plotted data on the x-axis, it would have been much harder to see than if we can compare to the network as a whole. And temporally, what I'd really like to do with this is show it more smoothly, maybe using sliding windows, because this discrete chunks makes it kind of hard to see trends. For instance, where did this emerge from? Did it emerge from a very local trend and come up like this, or maybe a global trend and it became local? Many of these questions could be answered with that. And I'll point out one thing we found in our investigations that filter zoom scales mean a lot in these cases. For instance, this is fairly zoomed out view, and if we zoom into this box here, which shows much more information, we can see kind of a lot of good discriminative results. But if we zoom in even more, it turns out to be a mess. So what we found to be useful was to set a fixed minimum threshold and a variable maximum threshold, setting the scales proportionally. So this is a heuristic, and finding an automatic way to do that is something we're very interested in doing. So to conclude, in this work we present a visual analytic framework which is helping to tell the difference between communities and social networks based on their content, based on what it is they're talking about. It's fairly simple because you can just scan some data and accumulate some frequencies and put them on a scatter plot. And it's pretty scalable because our methods scale well to million node social networks. And in the future, we'd like to look more at the temporal results and how to make them more intuitive and fluid. Finding more quantitative measures, because we looked at distance from regression line, but it seems like there's a lot of other interesting ones we could look at, and automatically determining the best scale at which to view these. Thanks. I'd be happy to take questions.